So, good morning, everyone. So, today we're going to go for chapter 2, which is about the network performance. Okay. So, when we talk about network performance, it would include your performance, latency, efficiency, okay, the lagging, and so on. Okay. So, at this chapter, it's going back to the modeling, network modeling part, where you will use the informations from your network modeling will be inserted inside this. Okay, so it is interrelated. So I hope last week's topic there is no issue with you. Okay, so how about your access to the simulator NetSim? Is there any issues? Okay, if there is no issues, so I hope you can proceed with your lab 2 this week. Okay, um you also required to write a report for each of the labs. Okay, as I mentioned last week, you have to produce 3 things. Okay, first, separated labs for lab 1 until lab 8 is being separated. The next one is the simulation part, the case study. You have to create another report where inside there you have to do some research to gain more information to ensure that what you are giving me the answer is correct. Okay, and then once you complete lab 1 until lab 8, you complete your case study, you need to compile them. Okay, compile into one final report. All of these 3 things you need to submit into your Spark and also your UOG portal, your Moodle. Okay, so you also required to include your zip file for the simulation that you have done. Okay, so network performance. So today we're going to learn about the application and traffic types, the performance metrics, the QoS or SLA. So this QoS stand for quality of service, while SLA is service level agreement. Okay, and then we will go into the reliability and availability, measuring and optimizing your performance, and we're going to look at the network and performance example. Okay, so application and types. So analog telephony will use analog sound. Okay, booking and reservation, it will conclude using the database transaction, while nightly backups, which is your files, it will, since it is a file transfer, okay, it considered as a batch. Okay, so email can be text, sound, image, and videos. Okay, so web surfing and searching, we go for real time. Okay, we go for real time. And it also one of the multimedia, because inside when you do the web surfing, it includes the GIF, it includes the videos, it includes the actions. Okay, when we talk about multimedia, it is a combination of different types of media, which maybe include your text, sound, image, videos. Okay, so all of that considered as a multimedia. Okay, and then CAD, CAE, and medical considered as a still image. Okay, internet telephony, radio, VOD, and TV, both of them are real-time audio, including the real-time audio. But when we talk about TV, video on demand, it will include your video. Okay, EDI, retail banking, educations, either it is distant or e-learning, or you are doing the uploading your file, downloading your file, all of this considered as a multimedia, data, and text. Okay, so type of traffic, just now I got mentioned to you, we have data, we have files, we have audio, we have still image, we have motion videos. So all of this is considered as a type of data. So For example, data or files. Okay, it can be written in binary. Can be written by text. Okay, which may include your documents, your emails, your DB queries, and web pages. Okay, well, for audio, it can be analog, it can be digital, it have their own various quality. Okay, still image is just a normal pictures. Motion video, it considered as your analog, digital, varying, which have various of quality, or we may know them as a sound picture synchronizations. Okay, so keep in your mind your audio and your video may be compressed. Okay, so performance of parameters and units. So these things you need to understand when it's include time. For example, your response times, your end-to-end or transfer delay, your delay variations, okay, your throughput. It requires to use timing measurements, which is second, microsecond, milliseconds, okay? So these things you need to remember. But it is special when we go for throughput. We need to have checking based on the bit per second being transfer or how many transactions can be done per minute. That's why it using bit per second and transaction per second. Next is the packet loss or your error rates. We will use fraction or percentage. How many percent of the packet being lost? Okay, sorry, how many percent the error rate? What will be the fraction value for the packet loss? Okay, maybe 1 out of 5, 3 out of 5. Okay, that is considered as fraction. Bar is your bit error rate. Okay, call blocking rate, we will also use fraction and percentage. Okay, beside all of this, we also have our network access delay, transit delay, and so on. So, how does the loss and delay occurs? Okay, so this one we'll need to go back to the class of network operating system. Okay, so you need to remember there is a packets. Inside your packets, you have frames, you have few components inside it. Okay, so usually we will use the packets to queue inside your router buffer before being forwarded. Okay, so the packet arrival rate to link can exceed the output link capacity. So packet will queue, wait for the turn to be processed. So your memory capacity to hold the queue is finite. And you can see that A and B is two different personal desktop. Okay, so A would send their information, B would send their information. Okay, so these two things, they will use the same network. So the packets will queue based on their arrival time. Okay, so they queue, the packets will queue, and it will known as a delay. So when your packet being transmitted, it considered as also one of type of delay. Okay, so free available buffers when your arriving packets drop, it would know your arriving packet would be lost if there is no free buffer. If the queue have empty spaces like this, okay, the white color one, the white color cell, it means that it still have free buffers. If the queue is full, so your packets would be lost or being dropped. Okay, so that's why they say the memory capacity to hold your queue is finite. They have their own space. Okay, so your packets needs to wait. Okay, needs to wait, needs to queue before it being processed. Okay, so there are 4 sources of packet delay for a single link. Okay, so this one, A and B are using a single link. So you can see that they only one transmission media. Okay, so one is the processing at the transfer nodes. Okay, it can be a computer or a router. So OS, operating system, will schedule. They will check for the bit errors, and then they will determine the output link. Okay. So next, after the process at the transmission link, they will go for queuing. Okay. So time waiting at the output link for transmission is usually depends on the congestion level of the router. Okay. So the third one is the transmission delay, where you will check about the link bandwidth, where you will use bit per second, the packet length using bits. Okay, time to send the bits into your link. Okay, so you need to check what are the time. Okay, next is the propagation delays. Okay, where the propagation delays is considered as transmission delay. Okay, D is the length of the physical link. Okay, S is the propagation speed in the medium. Usually, approximately, it will be 2 times 10 to the power of 8. Okay, millisecond. So your calculation for propagation delay would be D over S. Okay. So you have to understand that the link bandwidth and the propagation speed inside your medium are different quantity. Okay, so transmission delay usually they will sensitive to the technologies, which is your routers lah, okay, your PC lah, okay. While for propagation delay, it sensitive towards the distance, the length of your physical link. Okay, so far do you have any questions? No. So this is the example of the delays on the internet. Okay. So notice the delay variation. Which graph would be higher? Okay. Of course, the B one. Okay. So this is when we talk. This is the overall checking for global packet loss. Okay. We are using percentage for the 1 month. We are doing for the checking in the 1 month. Okay. So let's have a 5-minute breaks before we go for the bandwidth. Okay, so let's proceed. Bandwidth, or the other name of it is a bit rates. Okay, so before we go in further, we need to understand the numbers representation and units. Okay, because later on you will need to use this inside your calculation. Okay, so when we talk about powers of tens, we are using kilos, 10 to the power of 3. Okay, easy for you to remember, 10. Okay, and then how many zeros behind the 1? If you have 3, it means kilo. If you have 60, 10 to the power of 6, it is a mega. Okay, when it is a giga, 10 to the power of 9, where this 9 is considered you are having 9 zeros. Okay, including the one that is written at the 10. Okay, tera is 12. Okay, so fractions, for example, in seconds, millisecond. So 10 to the power of negative 3, it means that you 1 divide by 1000. If micro, 1 divide by 1, 0, 0, 0, 0, 0, 0. Okay, so same goes with pico. Okay, so just now I mentioned about analog and digital, right? So data can be analog, can be digital. Okay, for example, your sound. The normal human sound is considered as analog, but the sound that produced by the computers is known as a digital. Okay, so analog usually being measured using hertz, while digital is beat per second. Okay, so in the computer world, we reckon in the powers of 2. So 2 to the power of 10, which approximately is 10 to the power of 3. Okay, so typical bandwidth required for each of the application. For example, just now we mentioned about telephony. We are required around 3 to 20 kilohertz. Okay, for digital voice, we are using around 64 kbps, kilobyte per second, until 1.5 megabit per second. Okay, so this digital voice usually is uncompressed. Okay, uncompressed, the value, okay, the bandwidth required for uncompressed. Okay, bit, if we are having 10 kilobits per page, so we requires around 28 kilobit per second. Okay, which maybe we going needs to have around 0.35 second per page. While for image 1 megabytes, okay, you required around 1.544 mbps. Okay, you need to use the digital signal 1. While for motion, okay, motion video, as we mentioned to you just now, it is a pictures and sound that is being synchronized. Okay, so usually the size would be bigger. Therefore, you require, it's not required lah, you are essential to have a compression. Okay, so the 25 mbps to 2 gbps are required for the transpiration, okay, for the bit rate. So QoS requirements, okay, so different application will have different quality of service requirements. So later I want you to find out what is actually delay, what is actually jitter, loss, and bandwidth. All of this is different. Okay, so as you can see that for voice, video, and compressed video, you are required to have 250 millisecond for delay. But for image, you only require 1 second, data file few seconds, and while for transaction require 2 to 3 seconds. Okay, so I want you to find out what actually the meaning of delay, jitter, loss, and bandwidth. Okay, so next. Availability and reliability. When we talk about reliability, it is the probability of the network that will not break down over a period of time. Okay? When we talk about instantaneous availability, it is the availability of a network at a given instant. Okay? It means that when we want it now, it means that how was the probability of the network to be available if I want it now. Okay? But when we talk about availability, we are giving a certain period of time. Okay, then we need to check what will be the fraction of time that the network available within the required given period. Just now is I said now. It means it is now to check whether it can be available or not. What will be the probability it to be available? But when we talk about availability, it is a range of time that is not urgent. Okay, this is not urgent, but instantaneous, it is an urgent availability. Okay, easy for you to understand lah. Okay. Next, cost of downtime. This table given an indication of cost per hour of your downtime, but the actual values depends on the size of the company and exact nature of your business. So here, if you look at this, which one would suffer loss if downtime is occurs? Okay, good. Your answer is finance brokerage, right? So it's requires around 6,450K per hour if it is down. Okay, the second one, it goes for your media, which is pay per review. Then it goes for the retail part, catalog sales, and then it goes for media for ticket fee sales. And then we go for transportation package shipping. Okay, and then the last one is the finance on the ATM fees. Okay, so before we going further, let's take a 10 minutes break. Okay, Okay, so let's proceed. Leonhard Euler's number, or known as exponential. Okay, so exponential appears in several calculations performed by the network's engineer, okay, which include the availability reliability calculation. Okay, so how was the Euler's number being used? You need to check for below explanation. Okay, so exponential known as Euler's number. Okay, but please do not confuse with the Euler constant. This is two different things. Okay, so Euler usually is an irrational numbers. Okay, does not a ratio of an integers, and it cannot be a form of fractions. Okay, and E also is a transcendental, which is a not root of any non-zero polynomials with rational coefficients. Okay, and then the value of exponential truncate to 10 decimal places. Okay, so the functional exponential to the power of x is known as exponential function, and it is the inverse of the natural logarithm. Okay, so exponents is a raising a number to a power. Okay, so this slide is to help you to understand that various formulae that involve raising one number to the power of another, n to the power of x, which means that your n would be multiple for a few times. Okay, so x will be the number of repetitions lah. If, for example, we are using 10 to the power of 3, so it means that you have to times the 10 for 3 times. Okay, so you can see that below there, okay, below there, you can see if your x is 0, 2 to the power of x would be 1. 2 to the power of negative x is also 1. Where you replace the value of x inside the value of 0 inside the x. So you will get the value 2 to the power of negative 1. It's equal to 2 to the power of negative 0. You will get 1. Okay, but if you put 2 to the power of negative 1, you will get half. Okay, same goes with the exponents. Okay, so as you can see that the values, if you are using exponentials and others number as a power, okay, the value would be different, but it might be what we say uh sharper, okay, or it will say much more accurate. Okay, so this is where you will apply the calculation of availabilities and reliability. As I mentioned to you just now, availability and instantaneous availability is different. Okay, so for you to calculate RT, which is your reliability, you need to use exponential. Okay, to the power of time period divided by MTBF. MTBF is actually your mean time between fault, while your MTTR is mean time for you to repairs. Okay, so availability is equal to MTBF divided by the total of MTBS plus MTTR. Okay, while for instantaneous availability, you will need to use A, which is your availability, plus 1 minus A, which is your availability, exponential negative T divided by availability times MTTR. Okay? So this is the example. If your MTBF is 60 days, if your MTTR is 3 day and your availability is 0.952. So I want you to test and calculate and see what would be the value of instantaneous availability. Okay? So all of the information is written there. I want you to try now. I give you around 5 minutes. Did you get the answer? Okay, so next, this one. I want you to try this. Okay? Give you 15 minutes to solve this project calculations. Okay, so let's proceed. There are more examples later. We can do it at home. Okay, so I hope you able to perform all of these calculations. And once you do the calculations, you will identify that when you are having higher MTBF, you will have a higher reliability and availability. Okay? If you are having a lower MTTR, the higher the reliability and the availability. Okay? So actually us as a user or as a network engineer, we prefer to have a long time to break down. Okay? And we only requires short time to repair our network. Okay? If not, we are going to have a lot of loss when we perform our business. Okay? So, effect on reliability of mirroring the components. If we have two servers, each one have MTBF 1000, MTTR is 224 hours. So the application that only one need to be available. So that's why we need to do the instantaneous availability for only one server. Availability of any one of the two. So you will get the probability at least one is available is using the formula 1 and minus probability that both will be failed at the same time. Okay? So, a series of components. So, this component can be referred to your CPU, Ethernet card, cable, routers, and so on. So, all of these components need to be working to achieve the communication. For example, your CPU need to communicate with your network card need to be connected to your cables need to be communicate with your routers. So, all of this will considered as R1. So our CPU would be 99%, your R Ethernet card would be 99%, your R router will be 98%. So bear in mind, your R actually is your component. So how does we calculate the reliability? So each of them will be represented, CPU, for example, as R1. So we will take the value of the R1 0.99, okay, and then we will times with the value of Ethernet card, okay, and then we will times with the value of our routers. So we will get the overall values, okay. So far at this part, do you have any questions? So performance analysis, we need to do it when and what to be done. So when we need to cover when the initial designs or during the operation and when you want to do the upgrading. Why usually we want to do the upgrading? Because users need. And when we have a better technology. Okay, so what to be done when we do the performance analysis? We want to predict the performance. Once we predict the performance, we can identify our problems Once we identify, we can suggest improvements and we test the proposed changes to make sure that the problems are solved and our suggested improvement is really helping, okay, to solve the issues and not giving much more problems. Okay. So next, why do the performance problem occurs? It is due to the overload. Okay, overload can be temporary or it is a congestion. Okay, and then inappropriate choice of links or equipment when your component is failed, lack of planning for the application in use, simultaneous reboot, broadcast storms, poor tuning. Okay, so you will have buffers, timeout, retransmission packet size, and window size. Okay, so monitoring performance. We need to be done. Okay, there will be some few tools that you can use to monitor your performance and configuration inspection. Okay, so the first one is if config, which is your interface configuration, your ARP, okay, address resolution, your ping, remote host availability, RTT, trace routes, which your path taken, net state, your packet statistics and loss rates, your OmniPeak packet statistics, okay, protocols, NS lookup for your DNS query. Okay, so let's take a break for 5 minutes before we proceed. Okay, so if we have bottleneck, okay, we need to perform some troubleshooting. But how? Okay, so first thing first, you need to consider all stages in the source destination path. And then you need to test or eliminate each link or component systematically. Once you test, once you eliminate, you need to check, okay, for the software, the hardware, and the configuration that you have made. And then usually the modern protocols usually are designed to reduce or avoid the congestions. But okay, even though they are designed to reduce or avoid the congestion, but you need to understand that protocols need to be fine tuned. If not, it would not helping you anything. Okay? So next, performance prediction techniques. You need to know the measurements. You need to use the queuing theories. You need to perform some simulation. Either you use OpNet, you use NetSim, and so other simulation tools. But in your project latest, they already shared for your coursework, you need to use the NetSim, okay, where the access you need to request from UOG. NetSim is a licensed tool, okay, it's not a free, so you need to go and request the access. So the balance between cost, performance, and reliability. Cost, software, hardware, staff, installations, and maintenance. This one would be covered under cost. While we go for performance, it is the quality of your equipment, quality of your design, configuration setting, and your tuning. So reliability, high quality of equipment, the security measurements, the backup and mirroring for it, and redundancy. Okay? Okay. Let's take break. Okay, so network performance. We're going to see the parameters and examples. So traffic descriptor, network traffic is actually in the form of frames, packets, or your messages. To characterize the traffic, we need to identify their arrival rate or the packet's inter-arrival rate. And then the packet size, okay? So arrival rate, we use packet per second, but if packets inter-arrival time is in second, okay? Each of them have their own formulas, okay? So network capacity depends on the network components, which is your links, servers, routers, switches, and so on that have limited capacity to transmit or process your traffic. So capacity usually measured in bytes per second, bit per second, or packets per second, okay? So performance measures the load throughput and utilization, delay variation, or packet loss rate. So utilization is equivalent to load divided by capacity. Usually we will aim for less than 70%. If your load is less than capacity, everything is good. If not, you're going to have long delays, you're going to lose your packets, and a lot of other networks issues, okay? So, this is the formula for you to calculate the utilization, which is load divided by capacity. So, still remember, R is representation of your link bandwidth, which is in BPS. R, for example, if your R is 10 Mbps, the load on the link is 6 Mbps. So, how do you calculate? You need to use load divided by capacity, which is 6 divided by 10. So you're going to get 0.6. Then you times with 100% because we want to get the utilization values in percentage, not in a point form. Okay? To check a traffic flow or specific brackets, we need to use the formula TA into arrival time. And then we have our arrival rates, which is 1 over TA. And then PL. And then you're going to calculate your transmission time using packet length divided by your R, which is 10 Mbps. Okay? So, for example, they given you 100 Mbps, PL 1500 bytes. Okay, so how do you get 12,000 bits? Okay, then TS is 12,000 bit divided by 100,000,000,000. So you will get 0.00012 second, which is 12 microseconds. Okay. So utilization, you will need to use your 12 microsecond divided by your TA. Okay, so your TA just now is inter-arrival rate. Okay, so you will get, or you also can use A, your arrival rate, times with your PL, which is packet length, divided by your link bandwidth. Okay, next is a much more detail so that you can understand. So how does the byte can be converted into bit? What shall you do? Okay, Good. So this is how you calculate the utilization part. Okay. So this is the entity communications run all over the world. Okay, where we look at the website entity.net. Okay. So SLA is our NTT goals, okay, where it will covers for availability, latency, packet loss, and jitter. Okay. So usually we will need the availability is 100% all over the time. Your latency shall not exceed 50 millisecond for round trip in North American, but for the Atlantic, transatlantic monthly latency shall not exceed 90 millisecond round trip also. While for Pacific, it shall not exceed 130 milliseconds. Okay? But for packet loss, overall for global, okay, shall not exceed 0.1%. Okay? So let's take a 3 minutes break. Okay, queuing delay. Okay, so util proximate zero, you average queuing delay small. If your util is equal to 1, it means your delay is large. If your load is bigger than capacity, so more work arriving than the service can be done. If it is continued over a period, so your average delay would be go for infinity. That's why you need to aim 70% or so. Okay. So Ethernet utilization examples 100 Mbps. So consider you have 6 PC on a 100 Mbps fast Ethernet. Okay. So each of them are interconnected by a hub. Okay. Still remember your hub. then you need to assume that each of your PC will generate 50 frames per second on each average. So your average frame size would be 1500 bytes. So total load 6 times with 50 times with 1005 times with 8. Okay, so you will get 3.6 Mbps. So utilization, you need to 3.6 divided by your link. So you will get 3.6%. So far, do you have any questions? No. So I think you may proceed with your your lab practicals. Okay. And then see you after 2 weeks. Okay. So we're going to have our class on 9th of February. Okay. Which means is after CNY lah. But for weekday students, I'm going to see you on 3rd and 4th February. Okay. Thank you.